In this video, I will be demonstrating how to complete exercise 5 from homework 10. In this exercise, the height of notable tall buildings in America is compared to the number of stories of the buildings. And we are to use the stories as the independent variable and height as the dependent variable and make a scatter plot of the data. We'll do that first. And in order to complete all of this assignment, or this particular exercise, we're going to need to enter the data given into our calculators. I'm going to enter this data into my calculator with the, let me clear out my lists first. I'm going to put the stories in list 1, since that is my independent variable, and height is going to go into list 2 because it is the dependent variable. So let me get started here, and I will pause this so that you don't have to watch me typing. Okay, I've got them all typed in, and you might have noticed when I got started I'd put the wrong numbers in the first column. Now I've got it correctly listed here on this calculator. The stories are in list 1 because they are the independent variable, and the height is in list 2 because it is the dependent variable. Let's make a scatter plot of this. To make a scatter plot, press second and then press the y equals button right here. It says stat plot above it. We have plot 1 is on. If it is not on, you will need to, well, first of all, let's go ahead and go to plot 1 and press enter. Make sure that it's on. Notice that my on is sort of highlighted. The type of the plot, you want to be these dots. So if something else is selected like this, make sure you go to the dots and select that. The X-list and Y-list refer to the independent and dependent variables. So X-list is list 1, the independent variable, and those were the stories. And Y-list is list 2, the dependent variable, which happens to be the height. Finally, you can choose the mark. This is the, how it's going to mark each of the points. Just depending on how many points you have, you might want to choose one of these 3. I kind of like the plus sign. Once you have all of that, you can press graph. And I see that I have a line in my graph. Let me show you how to get rid of these lines if you have them. Okay. First off, press this y equals button. And you see that I've got some equations here. Let's get rid of those equations. To get rid of them, you can just press clear. Let's see. Okay, so I was interrupted by a student here. Let's go ahead and clear out the other things. Just go to each of these and clear them. So if you have something in your y equals menu, you can clear out everything. Now you can press graph, and it'll graph everything except for those lines. But now you don't see the scatter plot that we want. And to get the scatter plot, once you've got everything else cleared out and you just have the one plot, let me just double check. When I press second, stat plot, notice that plot 1 is on and all the rest are off. Once you're happy with that, press zoom. And notice that you have a bunch of zoom choices here. Most of them apply to function graphing. But down near the bottom, there is zoom stat. Zoom stat will zoom the calculator so that it looks nice with your statistics plots. Ah, that's much better. Bear in mind that this calculator, it doesn't mark off the point, mark off the axes. Although I think we can get that. Let me press a window. you'll find where it's the minimum, the maximum. XSCL is the scaling for the axis. It looks like if we put a little line every 10, that would be good on the x-axis, because the numbers range from 13 to 118. It might also be nice to start at 0. So let's go from 0 and count maybe every 20. Oops, 20. And then ymin looks like is 176. Let's change that to 0 as well. And YSCL, that's the markings that we're going to put. Let's go every 100. Now let's go every 200. I'll explain when we look at the graph. So once you get this, you can change that. Go ahead and click Graph. And here's what my graph looks like. You can see here these marks. Remember, we did this every 20. So along the bottom here, this is 20 stories, 40 stories, 60, 80, 100. Along the side, this is in hundreds, no, 200s. Each of these is 200 feet. So this is 200 feet, 400 feet, 600, 800, and so on. You can also figure out what each of these points represents if you click or press the trace button. Notice that that is the point 57 and 1050, which is the first point. And you can click the arrows to move within the points, and you can get the coordinates of each of the points if you're curious. So there you have it. I noticed that this doesn't ask you, it says to make a scatter plot, and we've just made the scatter plot on our calculator. You don't have the luxury of doing what I'm about to do. And so for you, you're going to want to either make your scatter plot using Excel. I'll show you how to do that as well. Or do it by hand. Probably Excel, since we're all using Microsoft products here. We could do that. So let me just show you that. Let's see, we don't need this. So go into Excel, copy the data. There's my data. Highlight that data, and then click Insert and Scatter Plot, and you want the first one. There it is. There's not much else to do. We delete stories. There, that looks nice, doesn't it? And I'm going to copy this. Well, you know what? I'm going to do one thing before I do that. I'm going to, under Layout, you can change axis titles. I want the title below the axis for the horizontal axis, and I want the title, this one, for the other axis. So this is feet. Let's see, height in feet. Change this. I don't know why it does that to me. Okay. Height in feet, and axis title down here. Oops, you can just click that and change this to stories. There. And you could also change the title, I suppose. Tall buildings. Let's copy this over and put it in our report. It's not our report. There it is. So I'll put it under A. There, that's pretty. Next, does it appear from inspection that there is a relationship between the variables? What we're looking for here is if a relationship exists between stories and tall buildings. And so I'm going to answer this that it appears that there is a relationship between stories and height. Specifically, as the stories increase, so does height. Kind of makes sense. Taller the building, the more stories, the taller it gets. So anyway, you can write something to that effect. I suppose if you are a minimalist, you could just say that it appears that there is a positive relationship between the two variables. Okay, calculate the least squares line. Let's go back to our calculators to show you how to do that. In order to calculate the least squares line, I'm going to go to Stat, go to Tests, and then go down to Regression. linreg t-test is the one that we want. So press enter, and you'll find xlist and ylist. There's a few other things here. For the most part, we're going to leave everything. We have the lists are L1 and L2. And then I'm going to set this to not equal to 0, because generally we're going to use that for our hypothesis test. And then go down to the reg equation. What this does is it allows you to actually enter the regression equation into the graphing menu, the y equals menu. So to get that, you're going to press the vars key, move over to yvars, choose function, and y1. It should look like this, and then you'll press calculate, and it gives you more information than you probably want. But one of the most important pieces of information is it tells you what the regression equation is. So let's go ahead and copy this down. Notice that at the top it says y equals a plus bx. Here is a, 102.42, and b is 11.75. So I'm going to just type that in over here. So let's see. I'm going to get rid of this y hat because it's annoying me. There's nothing wrong with it, it's just it's so tall. So we'll just make it y. So let's see, it was 102.429, and b was 11.758. And there it is. Now, by the way, you can, now that we've got all this information here, you can look in your y equals menu. So let's see, y equals, and if you did what I did and specified one of the y variables for the reg equation, you'll have it there. See, notice it's right there. Now we can graph the regression equation on the graph, but let's follow the rest of the problem here. So let's see, quit if you are looking at your reg equation. Next, it says find an estimated height for 32 stories and for 94 stories. We can do this in one of two ways, either by computing 102.429 plus 11.758 times 32, or we could let our calculator do this. And to let our calculator do this, you press vars, go over to yvars, and choose the function y1. In parentheses, put 32, and press enter. And what this is going to do is it's going to plug 32 into that equation that we just typed in over here. And I get 478.699. I'm going to round that to 478.7. And then if you press second enter, you'll get the previous entry. You can just change that to 94. And you get 1207.7. So let's see, it's 478.7, 1207.7. So let's see. Put this here. 478.7. Maybe I'll just go with feet in 9. 479 feet. And height of a 94-story building. How about just 94 stories? 1208 feet. You just go fix this. There it is. The estimated height of 32 stories is 479 feet, and the estimated height of 94 stories is 1208 feet. This came right from the calculator. Next, use the 2 points to plot a line on your graph. We can do this in one of several ways. Let me show you. Let's see. First of all, we'll plot those 2 points because it says that it wants us to. So let's see, insert. I'll just insert a little circle. Okay, so the first point, 32 and 478. Uh-oh, I just noticed that my graph is backwards here. What have I done? Ooh, I see. It's because Microsoft Excel, it switches these around. Let's see if this will work here. It still doesn't like it. I'm going to have to redo this graph. Sorry, you probably noticed this, and here I am. I'm supposed to be the expert. Let's go ahead and fix this. The stories are the x variable, and in Microsoft Excel, the x variable has to be on the left, and the y variable has to be on the right. So I'm glad I caught that. We're going to just make a new graph. There's my new graph. And I need to just change this. Tall buildings. We add in oops, there that goes. I'm going to add in some axis labels, titles. There's one there. This is height. Feet. And this is stories. So sorry about that. I had those two swapped. Okay, let's copy this into our document now. Get rid of this one because this one's wrong. Whoa. I didn't want that circle there. Okay. There. Okay, so this is better. Okay, so I'm going to do this. Now I'm going to work with this one. I believe it was 32 and 479 were the first. Yeah, 32 stories is 479. So I want to put a little circle right where 32 and 479 would be. So I'll put a little circle there. Let's see, 32 is right about here. And then 479 is right about here. So there's my circle. And then I'll put another circle at the other point. And the other point is 94 and 1208. Oops. Let's see, over 94 will be about here. 1208. That's just above the 1200 mark. Oh, I need to choose shapes, circle. Okay, so 94, 1208, right about there. Put a little circle there. That's good enough. So it asked us to plot those points. That was letter F. It says to also plot the least squares line on the graph. The least squares line is just a line that connects those 2 points. So let's go ahead and connect those 2 points with a line. So insert a line. And I'll fix this after I try. Pretty close. That looks pretty, oh, just a minute. I'm going to move it down. Right about there. There, you can fiddle with it if you want to make it closer to the correct position. But that's pretty good right there. So there's the least squares regression line. Notice that it goes closest to most of the points. Any other line is going to be further in total from the points than this one is. Okay, let's move on. Let's see, so we've done F. G, based on the above data, is there a linear regression relationship? Okay, now we get into the hypothesis test. So, whoops. We look at the calculator. Let's turn my calculator back on. And it's fallen off the screen, so I'm going to redo my regression. Since I've got all the data, it should be fine. So just go back to the tests and select regression, linreg t-test, and just go down and calculate. There it is again. And you'll notice that the p-value is 4.41 times 10 to the negative fifth. Since the p-value is 0.0000414. Is that what I have? Yes. And that happens to be less than 0.05. There is evidence to suggest that a linear relationship does exist. Are there outliers? Okay, so now this one is a little bit more complicated to deal with. Let's go back to our calculator. Our calculator will be most useful in figuring out outliers. To find your outliers, what you're going to do is you scroll through the linear regression information until you get to S. S is the standard deviation for the y values for this particular. It's actually a standard deviation for the regression line, I should say. So that's the number that we're going to use to determine outliers. What we will do is I will take the graph. So go back to this graph. And notice that since I selected y1 in my linear regression, it's got that line on there. That line is the linear regression line. What I'm going to do is I'm going to take that line and add and subtract two standard deviations. Actually, let me just double check some stuff here. I just wanted to double check that I was using the same numbers that your book uses. Sometimes people use 1.96, sometimes 2. But what we're going to do is we're going to take that line and graph it, graph a line that is 2 standard deviations above it and another one that is 2 standard deviations below it. The way we're going to do this is we take that 132.7, I guess rounded it's 132.8, go back to y equals, and go down to the y2 entry. And for y2, I'm going to do y1. So do, variables. Choose y variables, the function variables, and choose y1. And subtract 2 times, was it 132.7? I'm going to have to go back and make sure. Let me just double check. 132.8. Okay, so let me change this to 132.8. Oops. Okay, and then we'll do the same thing here, except for you're going to use 2 standard deviations above. This is like a confidence interval. You're making a confidence interval for the least squares regression line. In a sense, it's not exactly, it doesn't work perfectly, but as long as your points are within that confidence interval, you will, oops, that's 3 instead of 2, sorry about that. You will assume that they're okay, and anything outside this interval will be considered an outlier. So let's go ahead and graph these 3. So that's the lower limit. Here's the upper limit. Ooh, looks like one point might be outside the range, this point right here. To determine whether or not it is actually outside, press the trace button, and let's find that point. Oh, it looks like it's blinking. If it isn't blinking, you can move, you're using the left and right arrows. So I'll go left, left, there. And there's that blinking point. Notice that the y value is 1050, 1050. Now let's move the cursor using the down arrow to the line. Let's see, this is the middle line. The next one is going to be the bottom line. The next one's the top line. So I want to see where 57 is on this line. So now move my arrow back. Looks like it's going to be, this is pretty close. Notice that the y value here is 1036 when x is 56, whereas when x is 57, it's 1050 for that point. So 1036 versus 1050. The 1050 is outside the band of non-outliers. So there is an outlier, and it happens to be the point 57 is an outlier, and it is the point 57, 1050. Next one, we're going to compute the estimated height of a building with 6 stories. So we'll go back to the graph. Let's quit this. And then I think if I press entry enough times, no, I guess not. So I'll clear that out. Actually, it was this one. Yeah, there it is. So I just want to change this to 6. And let's put a period there, 6. So I want to know y1 of 6, and it gives me 172.9, or 173. The estimated height of a 6-story building is 173 feet. Whoops. So I have to spell correctly. This is not an accurate estimate because 6 is outside the range of values for the data. You see, if you have a point that's outside the range of values for your original data, then you can't trust the least squares regression line, because the further you get from your data, the less accurate your estimates will be. Finally, this last question is asking about what happens when you add an extra story. Well, let's go back to the least squares regression line. Where is it? Here it is. The least squares regression line says that y is equal to 102.429 plus 11.75 times x. What this means is that if you have a 50-story building and you compare it with a 51-story building, the 50-story, you could actually do this calculation. Let's go ahead and do it. Let's see, the 50-story building. Okay, the 50-story building is predicted to be 690 feet. The 51-story building is predicted to be 702 feet. Notice that that's about 12 feet. And that 12, it's actually 11.75, corresponds with this number here. So the equation, based on the least squares regression line, adding an extra story adds about 11.75 feet to a building. Get rid of that, and I'm all done.